Okay, so we have some descriptions of word problems that we're going to write the formula for the exponential function for, or the formula has been provided, and we're going to reverse engineer what those parameters are. So we're going to be finding A and R and B to fill into the word problem. So one of two ways, either you write the formula or the formula is given, and so you're filling in the blank on the word problem. So let's give this a try. Find a formula for P equals F of T, the size of a population that begins in year T equals 0 with 2,200 members and decreases at a 3.2% annual rate. So this 2,200 is my starting, so that's A. And this 3.2%, that's my R. And because it's decreasing, that's going to be negative. So I can find B is equal to 1 plus a negative 0.032. So that's at 3.2% as a decimal. And that'll give me 0.968 for B. So my formula here is P is equal to 2,200 times 0.968 all raised to the T. Number 18. In 2014, the cost C of a morning train ticket from Boston to New York was blank dollars. Assume that the price rises by blank percent per year. Find a formula to represent the price. So we're given C is equal to 126 times 1.05 raised to the T. So this is A, B to the T. So I know A is 126. My starting value is 126. And then to get R, I know that B is equal to 1 plus R. So 1.05 is equal to 1 plus R. And if I subtract 1 for both sides, I get that R is 0.05 or 5%. All right, you're going to continue this similar process with numbers 19 through 24. So go ahead and pause the video, give that a try, make sure you feel really comfortable identifying those parameters from the problem and then setting that equation up. Okay, so let's see if we got to some of the same places. Number 19, the population P of ants in your kitchen starts at 10. There's my A, and increases by 6% per year, so there's R. B is equal to 1 plus 0.06, which gives me 1.06. So P is equal to 10 times 1.06 to the T. So that'll tell you how many ants you have in your kitchen based on the number of days. Hopefully, in real life, you don't have any ants in your kitchen, but that is the formula that models this situation. Number 20, radioactive gallium-67 decays, so we're going to have a negative R, by 1.48% every hour. There are 100 milligrams initially. This is my A. Find a formula for the amount of gallium-67 remaining after T hours. All right, so B is 1 plus R, and R is negative here, so this is negative 0.0148, which gives me 0.9852 is my B. So my formula here is, let's use Q. They didn't specify a letter for a dependent variable, so you're welcome to use whatever variable you like. So that'll be Q is equal to 100 times 0.9852 all raised to the T. Number 21, the air pressure A starts at blank millibars at sea level, so that's when H is equal to 0, and decreases by blank percent per mile increase in elevation. All right, so we're given the formula here. So we have A, B to the T. So now my starting amount is 960. And then to find R, so I know that B is equal to 0.8, which is 1 plus R. And if I subtract 1 from both sides, I get negative 0.2 is equal to R. So that is a negative 20%. So I'm decreasing by 20% per mile increase in elevation. Number 22, an adult takes 400 milligrams of ibuprofen. I'm going to guess that's A. Each hour, the amount of ibuprofen in the person's system decreases by 29%. So that'll be negative. How much is left after 6 hours? So we're going to set up our equation, and then we're going to answer this question. So let's see. I have Q is equal to 400 times something raised to the T. So let's find our B. So B will be 1 plus R, which is 1 plus a negative 0.29. So it's negative because we're decreasing. So it gives me a B of 0.71. I'll fill that in here. So there's my equation. Q is 400 times 0.71 to the T. And then how much is left after 6 hours? So we're looking for f of 6. So we'll plug 6 in for T. So Q is 400 times 0.71 raised to the 6th, which turns out to be approximately 51.24 milligrams of ibuprofen left in our system after 6 hours. 23, the bear population P increases at a rate of blank percent per year. There are blank bears this year. Write a function that models the bear population. How many bears will there be in 10 years? So P is equal to 1573 times 1.02 to the T. So here's my A and my B to the T. So we're starting with 1,573 bears. And B, which is 1 plus R, is going to be 1.02 is equal to 1 plus R. So R is 0.02 or 2%. Okay, so the number of bears is increasing at a rate of 2% per year. And after 10 years, we'll have 1573 times 1.02 to the 10th, which gives me about 1,917 bears. I'll plug that in my trusty calculator. Right, last but not least, number 24, each year the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So this half are eliminated. That tells me that R is negative 0.5, which means that B, which is 1 plus R, is going to be 1 plus a negative 0.5, which gives me 0.5. So Q, and there's my A here also. Q is 128 times 0.5 to the T. And after 5 rounds of play, we're going to have 128 times 0.5 to the 5th players left, which turns out we're just down to 4 players after those 5 rounds. All right, so hopefully that gives you some insight into taking a word problem and putting it into an equation, or if you're given an equation, figuring out what exactly is going on there, what the initial value is, whether it's increasing or decreasing, and by what rate, what percentage rate that's changing.